In this video, I want to focus specifically on how to determine the formula for ionic compounds and how they come together to form different patterns when they form compounds. So first off, something we've mentioned before. So cations have the positive charge, anions have the negative charge. We'll talk about electrons in a minute. So if we just look at a specific example, and we've used this one before, sodium chloride. So a couple things about this salt that forms between sodium cation and the chloride anion. One thing to note is that they come together due to attractive forces. Right? So in our universe, for whatever reason, positive and negative are just attractive to each other. And so they just naturally cluster together. And they don't just cluster together randomly. That's important to note. Okay? These things always cluster together in a very specific ratio. And for sodium chloride, it's a 1-to-1 ratio. The reason why that is because the charges are equal and opposite. So basically, this ratio that you see here for each salt is dependent upon the charges that are on the ions. Now, I've already pre-filled this in a little bit. So the ones that I've highlighted or bracketed off in red, you should know these. These are ions. These are elements that only form one particular ion. And we've addressed this pattern before. +1, +2, +3, -3, -2, -1. That is a very common periodic trend to know. We first saw it back in, I think, chapter 4. This 1-to-1 ratio in salt formulas, it can occur for something like, let's say, calcium and sulfide. They have something in common with sodium chloride. The charges are equal and opposite. So again, what's the simplest ratio? What's the empirical formula for this salt? Simplest ratio that they can come together so they cancel out each other's charges. It's a 1-to-1 ratio. There's other examples that, takes a little more work. Let's say magnesium fluoride. All right, if I brought these together in a 1-to-1 ratio, well, what would happen is that the positive charge would not be completely canceled out. Nature just doesn't do this. Instead, what nature is going to do is going to bring one of these together for every 2 of the fluorides. Couple ways that I know that this happens, okay? Ultimately, it's a way to balance out the charges. If I had 2 fluorides, that's going to be a total of -2, and that's going to cancel out the +2. So there's the formula for magnesium fluoride. And then the other thing that's often mentioned is there's this pattern. Okay, so the charge on one can tell me how many of the other substance I need. -1 charge on the fluoride means there's 1 magnesium. So you can do this flip-flop of the numbers there. This works for any set of ions unless, the example is previously stated where they're coming together in a 1-to-1, the simplest form because of the equal and opposite charges. As you can see, there's a lot of different cations. There's quite a few anions. And something that's not shown, but pretty much all of these transition metals can form a cation. So there's almost an endless number of examples that I could do. But it's all the same pattern. So speaking of this flip-flop rule, it's illustrated on the next slide, right here. Right, when aluminum and oxide come together, right, you can really move the numerical values around. And again, why are we doing this? Aluminum has, where there's 2 aluminum cations in that formula, there's 3 oxide. And again, ultimately, the reason why they're doing this, because this is going to be a +6, 2 minus 2 minus 2, that's a -6. And that's what we see, right? Charges are going to cancel out. That is true for any ionic substance. Briefly, right, we've seen this one before, so I'm going to sort of run through it quickly. We know what charges they form, again, because of this periodic trend that we should know. We've seen before. How does magnesium get the +2 charge? Well, it's going to lose electrons. And sometimes we write it this way, as a chemical reaction. How does oxide get the -2 charge? Well, oxygen is going to gain 2 electrons. And then once they have that formula and that formula, then they're going to come together. Equal and opposite charges, MgO. And that would be the formula for that compound. So, for example, when magnesium and oxygen react together, the model is magnesium loses 2 electrons. Those 2 electrons that are lost are gained by oxygen. So this transfer of electrons is really what is responsible for the formation of ionic compounds. Couple practice problems. Again, like before, I would suggest pausing the video, working on the problems, starting the video back, and then you can see the answer. Now, what it's doing here is, it's not open-ended, but it's, when you first read it, it may seem a bit vague. You know, strontium, chloride, aluminum, and nitrogen. What you have to realize here is that all of these elements, strontium, chloride, aluminum, and, well, it'll be nitride in a second. What are the charges here? Well, they are here. There's strontium, there's chloride, there's the nitride, there's the aluminum. And so part of answering these questions is realizing how we determine the charges on these different substances. And the way we determine charges is from this periodic trend that we've been talking about for the past little bit. And now we can use, like in this case, we can just simply use our flip-flop rule. There's 2 of the +2 charge on the strontium, so I need 2 chlorides. There's a -1 charge on the chloride, I only need 1 strontium. Right? We sort of move those numbers around. Here, for aluminum and nitride, equal and opposite. So they did just come together in a simple 1-to-1 ratio. If you did Al3N3, that is incorrect. For ionic substances, we're looking for the simplest whole number ratio that these ions can come together to form a salt. In the next video, we'll start officially naming these compounds.